Okay, example 2 here. So calculate the final value of an investment savings plan based on saving 600 at the start of each year at 4% per annum for 5 years. Okay? So at the minute, this has nothing to do with pensions or present value. Okay? There's more to this question, but at the minute, what they're asking me, this is the important word. So calculate the final value of an investment savings plan. So we're saving 600 at the start of each year at 4% per year. So, and I want to know the final amount of that savings plan. So I'm saving 600 and it's going to earn interest in the first year. Okay, and so on. We know we've reversed our series, okay, where this is actually the first month, or first year, sorry. Okay, so that €600 is in there for 5 years. It's earning 5 years worth of interest, and so on. Okay, so basically this is like what we did 2 days ago. It's your geometric series. There's your A. Your OR is that, and we're looking for sum of the first 5 terms. Okay, we want to find out what's the final value of this plan. How much am I going to have in the account after 5 years? So A, 1 minus R to the power of N over 1 minus R. Okay, so the final amount is 3,379.79. Okay, I'm just going to check that. Yeah, 3379.79. That's perfect. Okay, so that's part 1. I'm saving 600 each month. It's going to earn it each year. Sorry, it's going to earn interest each year. So I'll end up with 3,379.79. Now, part 2 of that question. Okay, let's just keep that in mind. That was my answer. Okay, part 2 here now. Calculate the present value of these payments. Now, that's not calculate the present value of the final amount. It's the present value of each of these payments. Okay, so I'm looking, I know I'm saving 600 at the start of each year. What is the present value of each of those 600s? Now, the important thing is I'm saving it at the start of the year. So the present value of the first 600 that I save is just 600. Okay, I'm saving it at the start of the year. So the present value of that 600 is just 600 because it hasn't earned any interest in the year. Okay, so that's important. This is where it changes slightly. Now, the 600 that's going to be in there for a year, the present value of it will be this. Okay? 1, 2, 3, 4, 5. It's not going to be divided by 1.04 to the power of 5. Okay? I do have 5 terms. I'm actually going to write it out because I think it'll be easier. So this one is to the power 2. This one is to the power 3. Now it's 5 years, 1 payment, 2, 3, 4, 5. So the difference here is that it's to the power of 4. The reason it's different is because our first year didn't actually earn any interest because it was put in, the present value is 600. It is happening now. So no interest has happened because no time has passed. So this is where it's slightly different to what we were doing in class today. This is if we work backwards. This amount, I'm earning interest on 4 years. Okay, 3, 2, 1, and I'm not earning any interest in this because it's happening right this second. Okay, now when you go to your series, it's pretty much the exact same thing. The only thing that's happened is your A is different. So your A is 600. Your R is still 1 over 1.04. okay? And your N, there's still 5 terms, okay? So just because this is 4, that has nothing to do with my N. My N is the number of terms in my series, and I still have 5 terms in my series. So when you're saving at the start of the month, and we're interested in the present value of that saving at the start, the A is the only thing that changes, okay? So I now have my geometric series, and I'm interested in the sum of these 5 terms, A by 1 minus R to the power of N. So we know this whole thing's to the power of 5, but 1 to the power of 5 is just 1, all over 1 minus R. And I'm going to throw that into my calculator. 1.04 to the power of 5. Close that bracket. Okay, and put it over 1 minus 1 over 1.04. So what we get is 2777.94. That's the present value of all of those savings, okay? Part 3 now is show now. So show that if the present value, this is your present value, was put on deposit for the same length of time. So if I actually just put this into an account for 5 years at 4% interest, it would end up with the same final value. I would end up with that amount. Okay, so whether I'm saving 600 per year, for 5 years, or whether I put the whole amount in for 5 years at the same interest at 4%, I should get the same answer. Okay, so this is my present value. I'm saving it. Okay, and I'm interested in having the same final amount, so I'm finding F. Now, this is what I'm putting into the account. I'm doing it at the same rate. So the rate was 4% for the same amount of time, so that's 5 years. And we're hoping that it has the same value as this, which it does, 2777 by 1.04 to the power of 5, 3379.79, which is what I got when I did it as installments. Okay, so you end up with the same amount.